So I want to have a look at another type of pattern, and let's just check out which type this is. So let's check if it's linear. So common difference, well, a difference of 2 there, a difference of 3 here, a difference of 4 there, so it's not a common difference. 5 there, 6 there. Let's go for a second difference. Yeah, 1 every time. So if you remember, even to do a differentiation, it takes two rates of change to find a constant when you're differentiating an x squared. So this is a quadratic. Now, if I asked you for, you know, the 10th part of the pattern, so that'd be grand. You know, you had 2, you had 3, you had 4 to get to the next one, you had 5 to get to the next one, you had 6 to get to the next one, you had 7 to get to the next one, you had 8 to get to the next one, add 9 to get to the next one, add 10 to get to the next one, etc. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's your 10th part of the pattern. So T10, you know, I don't need to do anything with that except just go up bit by bit, get with my calculator. But if I asked you for T100, that's different. You don't have time in the exam to do that. So there has to be like the key to the formula, or the key to the pattern here. And what does any quadratic look like? So what you've seen in functions is like something x squared plus something x plus something. That's what a quadratic normally looks like. You know, you should be sick of seeing quadratics, so this should look somewhat familiar to you. Now, because our variable is n, you know, instead of the x I might put in an n, but it doesn't really matter. So it's something n squared plus something n plus something. That is kind of like the generally what a quadratic looks like. So if we keep that in mind, what I would do now, if you've never, again, like I said this before, if you've never done these questions before, I would pause the video and see if you can figure out maybe this and eventually what T100 is. If you have already seen it, well, maybe you just want to keep going through, because I'm just going to explain it now. I'm going to explain it 2 ways. So the first way is, okay, so what do I know here? I know that the first term, so T1 is equal to 1. I know that T2 is equal to 3, etc. So T1, so when n is 1, the whole thing is equal to 1. So T1, so when n is 1, the very first term is equal to 1. So I clean that up. And I end up with that. Now, that might, you know, start to maybe look a bit familiar, like an equation with 3 things missing. Maybe I'll go again, because if I'm going to do simultaneous equations with 3 things missing, I'll usually need 3 simultaneous equations. So I have more information, T2. So when n is 2, term 2 is equal to 3. Clean that up. Okay, I have a second one. And T3 is equal to 6. So anywhere I have an n, I'm going to put in a 3 now. And T3 is 6. So that gives me 9a plus 3b plus c equals 6. And there we go, 3 equations, 3 things missing. Off I go and just use my algebra to solve that. So I have a plus b plus c equals 1, 4a plus 2b plus c equals 3, and 9a plus 3b plus c equals 6. So I'm going to take these two and I'm going to get rid of the c's. So I'll just take this line and leave it as it is, the 4a plus 2b plus c equals 3. And I'm going to take this line and I'm going to multiply it by minus 1. So that's minus a minus b minus c equals minus 1, which gives me 3a plus b equals 2. I'm going to do this again. I'm going to take this line and this line. So I'm going to write this line just as it is. So I'll do it here. 9a plus 3b plus c equals 6. And then I'm going to multiply this by a minus 1. So minus 4a minus 2b minus c equals minus 3, which gives me 5a plus b equals 3. So now I'm going to leave this equation just as it is, 3a plus b equals 2, and I'm going to multiply this by a minus. So minus 5a minus b equals minus 3. So a is equal to a half. Why do I want that? Well, now I have coefficient of the n squared back up here. I'm going to keep going. I have 3a plus b equals 2. So 3a plus b equals 2. So that's 1.5 plus b equals 2. So b is equal to a half also. And then c, well, a plus b plus c equals 1. So a plus b plus c equals 1, leaves me with c is 0, which means that general term is equal to a half n squared plus a half n plus 0. So I can just leave it like that. And this allows me, right, if I want T100, a half 100 squared plus a half times 100, throw it into your calculator and you have your answer. So this is your key to your question or to your pattern now. There is another way of doing it a little bit faster. So I'll just explain this because some of you might have a good understanding of differentiation. So if you think about it, you know, if you differentiate twice, you bring the power in front, you subtract one from the original power, then you bring the power in front, you subtract one from the original power. So by the time you get to here, we actually know that there's a big link between what this was and what this becomes. And, you know, have a think about it. I'm not going to go into good detail here because, you know, we already have a method. But if you do want to speed it up, you can actually notice that the coefficient of the n squared is always going to be half of this here, your common second difference. And if you know that, well, it actually allows you very quickly at the start to go, right, that's generally what a quadratic looks like. This particular quadratic has a second difference of 1. So that means that I already know or understand that I already have the coefficient of the n squared. It's always going to be half my second difference. And then that leaves me still with some algebra, but not 3 equations, 3 things missing. I'd end up with 2 equations, 2 things missing, and I'd be able to solve it faster. Okay, so if we look at our sequence, we have 1, 3, 6, 10. Etc. You know, if we wanted to add this up, grand, I get out my calculator. Is there a fast way to do it? No, there actually isn't a fast way. So for a linear, yes, there is a fast way. You go to your log tables and you use your SN formulas. But for a quadratic, there is no fast way of summing up a quadratic except taking out your calculator and bit by bit adding it up.